So, very good evening to all the participants and happy Teachers' Day to all the participants. And we'll start our session 9 of our FDP. And the speaker is Dr. Debabrata Giri. Let me introduce Dr. Giri. Dr. Debabrata has over a decade of techno managerial acumen in various quality domains, project planning and execution, product development and procurement, cost innovation, program management, vendor management, upgradation, establishment, world class quality, TQM, failure analysis, and Six Sigma problem solving. Worked with leading Indian automotive MNCs like Mahindra and Mahindra for the passenger car and Tata Motors for the commercial vehicles. Currently, he is working as a deputy general manager in Tata Motors, Jamshedpur, in the division of MSCV and defense vehicle of Tata Motors. Also, TQM Secretariat for Quality in Research and Development, Design and Prototype Production in Tata Motors. He is also the winner of multiple events in national and international industry and quality forums like NQ Japan, SAE, IIIE, INSSAN, CII, etc. He is also the founder of, you can say, the very fond of this numismatic museum. You can say the Kalinga Heritage he has formed, where 1,000 plus coins, paper monies, FDC stamps, weapons, and many other items are being displayed. And he is also the recipient of APJ Abdul Kalam Award, National Pride Award, and the Indian Excellence Award. So I welcome Dr. Giri to this meeting and to this FDP, and I request him to share the screen so that the session will start.
Yeah, thank you. Thank you, Dr. Patnaik, for such a brief introduction about myself. Happy Teachers' Day to all. Let me share my screen.
Yeah, it's visible. You can unmute yourself, Dr. Giri. You can unmute. You can unmute.
Hello, Dr. Giri. Just first you stop sharing screen, then unmute yourself, then start sharing.
Hello.
Yeah. Now it's audible.
Am I audible now?
Yeah,
Yes,
yeah,
yes.
yes.
Okay. And can you please confirm if my screen is visible?
Yeah, it is visible.
Yeah, yes.
It is visible, yes. So before starting the session, I want to say one thing that I am working in research and development of Tata Motors, and I am leading engineering quality function for commercial vehicle, that is civilian as well as defense vehicle. And whatever new technology is coming in Tata Motors, that is electric vehicle, LNG, CNG, hydrogen, internal combustion engine, we are well versed and aware of the technology, but many information I will not be able to share with you. But what is I have been permitted by my organization, that I will share. And in between, please stop me whenever you have any query or you want to discuss any point. Please stop me there. We will discuss. So before starting the talk, I want to introduce my organization, Tata Motors Limited. It is a salt to software conglomerate, and I think Tata Group doesn't need any introduction. Despite of that, in the nutshell, we are a 165 billion US dollar combined revenue company where more than 1 million workforce is working. We have presence over 6 continents and 100 countries, and these are some of the key group companies: TCS, then Tata Elxsi, Tata Digital, Tata Technology, Tata Electronics. Now this Tata Electronics has set a plant in Bangalore where we are manufacturing Apple phones. Then Tata Steel, Tata Motors, Jaguar Land Rover. It is the largest automotive company of UK. And recently we have acquired Iveco. That is the largest commercial vehicle of Italy. With that, we will have a very good global footprint in commercial vehicle. Then Tata Autocom sister. This is Autocom Systems. It is a sister concern which supplies automotive component to Tata Motors. Then in tourism and travels, we have Indian Hotel Group, then Vistara, Tata Air India Express, then Air India. Air India was previously Tata Group company only. Then during nationalization, during the period of Indira Gandhi, Indian government took over. Then again Ratan Tata take it back to Tata Group. So in consumer and retail, we have Tata Chemicals, Tata Consumer Products, then Voltas, Titan, Trent, Chroma. In infrastructure, we have Tata Power, Tata Projects, Tata Housing, Tata Realty. In financial services, we have Tata Capital, Tata AIA, Tata AIG, Tata Assets, like that. In telecom, these are the companies we have. In trading and investment, we have Tata International and Tata Industries. In aerospace, we have Tata Aerospace. Then if we come to Tata Motors, then we are the flagship company of the Tata Group. We are home to iconic brand Jaguar and Land Rover. We all are proud of that. And recently, the CEO of Jaguar and Land Rover will be an Indian, PB Balaji, and he was earlier chief financial officer of Tata Motors. Now he will be CEO and MD of Jaguar Land Rover UK. First time in Indian is going to take over that company, means as a CEO. Then total sale volume is this. This is excluding Jaguar Land Rover. This is the group revenue. We have presence over 125 countries. Collective workforce is more than 1 lakh now. Then proud to say that we are the number one CV brand in India with more than 50% market share. And number third in passenger vehicle. After Maruti, Hyundai, Mahindra, Tata Motors, these four are always competing with each other. So we are in number 3. Then in EV, electric vehicle, we are number 1 brand in India with more than 80% market share in passenger segment. Then for automotive, we have key subsidiaries like Jaguar Land Rover, Tata Motor Finance, Tata Doyo South Korea. We have a global presence in commercial vehicle, Tata Technology. The strategic partner are Fiat. With at Fiat plant we make Tata Nexon, then Tata Cummins, which supplies engine to Tata Motors, commercial engine. They have 2 range of engine, 5.6 and 6.7. So they are supplying Tata Cummins engine to us. Then Cherry, Tata Rise, Agritas, where we make EV batteries. It is a UK based company, Agritas. It has a joint venture with Jaguar Land Rover to make them electric ready. Then Fiat Tiger. Coming to company profile, am I audible, right? Can somebody
Yes,
confirm?
yes,
Yes,
yes, yes.
yes, yes. Then M and HCV is medium and heavy commercial vehicle. M and HCV, medium and heavy commercial vehicle. Where for Jamshedpur plant, our vehicle range from is 19 ton to 60 ton for domestic market. Excluding that, we are exporting to 36 countries. Then 55% of the CV is commercial business. Commercial business revenue from Jamshedpur operations. Then for defense, we are supplying vehicle to CRPF, BSF, Ordnance Factory, then DRDO, BEL, DGP, police, like that. Then for aggregate business, we are manufacturing for our Lucknow plant, Pune plant, and Dharwad plant. We are catering their aggregate business from Jamshedpur location. Coming to technology, we have two type of engine. One is Cummins supplied engine. Second one is 5-liter engine. 5-liter means 5000 cc engine that is used in commercial vehicle that we manufacture in house at Jamshedpur. Then for electronics, we have flashing and diagnostic technology, and we have robotic for framing and door hemming technology, which is done by robot. We are using robot in many operations actually. Then camber correction, cut to length, including we have a 5000-ton press that is used for making the long member, means that we call frame. Then we have CD painting, CNC punching, we have paint shop. Then these are the technology available with us. Then coming to product, then I told we have three type of product: truck, tractor, and tipper, and another is defense. Then plant capacity is 440 vehicle per day that we are making here, 440 vehicle per day. And if you take the pollution norms, we are making from BS1 to BS6. BS6 we are catering to India, but for Bangladesh, Sri Lanka, Middle East, they have not reached BS6 yet. So as per their local requirement, whether they require BS3, BS4, BS2, we are providing them such pollution compliant vehicle. Then we are total making 400 type of vehicle, that is vehicle combination is 397. Then many part we are sending to CKD kit, where we send the loose part from here and assemble it the country which in which we are doing the business to get the tax benefit and shipping volume, meaning optimize the shipping volume. Then coming to the journey, this Jamshedpur plant was established in 1954 with bench. There was a joint venture between Tata and Mercedes. With we are making this type of truck. In old movie, you must have seen this type of trucks. We called it SFC, semi-forward cabin, where a nose type of structure will be projected from the truck. So we started with that. Then now our facility is spread over 600 acres, and if you can include the township, then it is more than 1250 acres. Then product I told over 400 type of model ranging from 19 ton to 60 ton. Then we are ISO 50001 company. Now we are embarking on a journey to use renewable energy. We have new technology like CNG, LNG, EV, H2IS. Then we are the first company in Eastern India to achieve a prestigious Greenco Gold that we received from our president, respected Draupadi Murmu last year. And this is the pictorial form of product portfolio. Truck, then tipper, then tractor. I will come, means what is truck, what is truck. If you see, this is the truck. It is used for carrying the load, where load carrying capacity is 19 ton to 45 ton. Engine used are 5 liter and 6.5 liter. Then tipper, that used for construction, load carrying and mining activities. This is the tipping body. It can be lifted up for ease of operation. And these are the tractor. You will see the long vehicles carrying steel roll or car like that. This is the tractor. Again, this is the portfolio in which ton we are making which type of vehicle. An engine we have from Cummins, we have Asomet 5.6 liter, 5600 cc. Then Atulya, it is 6700 cc vehicle. For Tata Motors, we are making 5000 cc vehicle. And these are the type of gearbox, and these are the type of rear axle. And these are some of the product we are using for defense project. It is one LPTA 2445. 24 is GVW, gross load is 24 ton, and 45 means into 10, 450 HP engine. This is the nomenclature. We are sending to Moroccan army. Then this vehicle LPTA 60 that was used for Agni missile carrier that we are sending for DRDO. Then this is LPTA 3945 MRSM. MRSM is medium range surface to air missile launcher. Again, we are sending to Indian Army. Then it is BrahMos. You can see many of these vehicles used in recent India-Pakistan agitation. Anyway, this is 73-ton tank transporter, and this is a 12. This is the oldest vehicle Tata Motor used to make with Mercedes-Benz. These are some of the vehicle that we are catering for defense customers. Then coming to the main topic, first I will cover since the topic is regarding advanced material and advanced technology. So I will cover advanced sustainable mobility through EV, LNG, and CNG integration in Indian heavy trucks. So I will not discuss the internal combustion engine. I will discuss what is beyond internal combustion engine, means diesel and petrol engine. I will discuss beyond that. So if I'll discuss the sustainable mobility, then apart from this technology, I need to say what you are doing to achieve the sustainability. So for sustainability, we have implemented ISO 50001 energy management system, then adopted environment management system, then digitalization industry 4.0 that we have already implemented at Tata Motors. Then as a Tata Motor, we have committed by 2045 we will be a net zero company, means total CO2 emission will be zero, not only at Tata Motor, but if we'll include our vendor partners, means tier 1 and tier 2 suppliers, they will be also achieving net zero with us. This is a commitment by Tata Motor to our mother earth. Then energy efficient process and products. Then what innovation in energy conservation we have done? Okay, I'll escape this. Green supply chain management. Then sustainable guideline for suppliers. We have made a guideline how to achieve the green supply chain. Then this is the strategy, means for communication what to do. Then capability building at supplier end. Then we do have a periodic assessment at supplier end. Then recognition who has done very good in sustainability. We have done a supplier evaluation process. Then these are some of the meetings we conducted for supplier awareness, and there are the number of supplier cover. Then there are something that implemented at supplier, and I will not cover this because see energy management system how we implemented industry 4.0, different type of digital architecture. I will not cover this. Coming to the main point, EV adaptation in heavy commercial vehicle. See, for EV adaptation, we have to develop the advanced powertrain technology, including electric, alternate fuel LNG, CNG, H2S, and H2 fuel cell. Then collaborative effort with Cummins India for H2S technology. They are the two things we have done. Coming to the question, why electric vehicle? Why we need to adopt the electric vehicle? First of all, if you will see the recent conflict between India and USA, it is all about fossil fuel. We are getting crude oil from Russia. That's why US is not happy. Donald Trump is not happy. He's putting some uh, extra charges on what we are exporting to their country. So everything is about fossil fuel. So if we adopt the electric vehicle, then our dependency on this fossil fuel will decrease. And secondly, if you'll see, a country will grow if its trade deficit will decrease. And whatever you are importing, major chunk of that is our importing crude oil. If we reduce the crude oil import, then trade deficit will decrease. Accordingly, the country will grow. So that is why we need to reduce this fossil fuel import. That is why electric vehicle is important. Then global warming and harmful emission in ICE engine. ICE engine generally contribute to CO2, CO, then NOx. So with adaptation of EV, then global warming and harmful emission will decrease. Then coming to tailpipe emission, you will say if my source of electricity is not green, if I am burning coal to use the electricity, then what is use of EV vehicle? You will say the total pollution is not decreasing because I am producing electricity by using by burning coal. I will say there is two reasons to adopt the electric vehicle. One thing is if I am burning diesel or petrol to making the to run the vehicle, then efficiency of ICE engine is very less, 18 to 20%. If I'll increase it, then it is a big thing, means improving the efficiency of ICE engine. But the efficiency of motor is very high, it is more than 90%. So one thing is efficiency. Second thing is, if you are using ICE vehicle, internal combustion engine, there is 100% chance that you are burning fossil fuel. But if you are using electric vehicle, then the source of electricity may be green, may not be green, but there are chances. If you are using electricity from solar energy, from wind energy, from wave energy, then there are chances of green electricity. So two things. One is probability of generating electricity through green means. Second is efficiency. That is why EV should be used. Third point is zero tailpipe emission. Suppose I am running a vehicle in a town, correct? So whatever pollution that will be made by the vehicle running inside that town. So the harmful material, harmful gases, CO2, carbon monoxide, carbon dioxide, NOx, that will be exhausted in the habitat, means where humans are staying. So that is called tailpipe emission. Suppose I am generating electricity. Generally, power plants are away from the human habitats, so it will be polluting at those area only. At least human race will be safe from that majorly. So that is why it will reduce the tailpipe emission. Now coming to uh, cost. If you see the cost per kilowatt hour year by year, it is reducing for high voltage battery. From 2013 to 2024, it has become one third, even more than one third, and we are expecting it will decrease further by 2026. So that is another reason to adopt EV vehicle, because cost is decreasing. So your initial cost for buying the vehicle will also decrease. Then total cost of ownership, I will describe this in a separate graph going forward. But total cost of ownership also decreasing. And if you compare, then total cost of ownership is less than that of ICE. If you cover the total life cycle of a vehicle. Then high conversion efficiency, that I already discussed, that efficiency of electric motor is more than that of ICE engine. Correct. Then coming to challenges of electric vehicle. First of all, EV architecture needs lot of research and development. That is why Tata Motor is got the first mover advantage in India for passenger vehicle. Tata Nexon was launched. It has more than 50-60% market share, and other adapters that are following us. Then specific power versus specific energy graph of different battery material. Then HB battery technology. Still, we are struggling with that. How to improve the power to weight ratio in electric vehicle. Then infrastructure. In India, still till now, the charging station availability is a concern. So if there is no charging station, then there will be always a range anxiety. Means for how many kilometer my vehicle will move, and when I will get a charging station, that is still a concern. Then standardization of charging adapter, that already we have done. We have raised this issue to the government of India, and now CCS2 type of charger has been standardized in India for both for passenger vehicle and commercial vehicle. CCS2. Earlier, different type of charger were used. You can see there are four type of chargers. Now it has been commonized. Like in mobile, everybody is now using C-type charger. In same manner, for EV vehicle, we are using CCS2. Then battery cell manufacturing infrastructure. Currently, if you will ask me, we have a dependency on China. Still we are getting the battery pack from China, and just making it series or parallel connection based on our voltage and current requirement and using it. But Tata Group is doing research and development, and we are almost done to do it make in India, so that our dependency on China will be finished. That we are doing. We have a sister concern, Tata Goshen, that is part of Tata Group, Tata Group company. With them, we are developing this battery cell manufacturing infrastructure. Then battery recycling is a concern because a lot of harmful material are in battery. So government has made a standard how to recycle it, and we are making that infrastructure for Tata Motors as well as Indian government is taking a lot of effort on that. Then this is another challenge: battery cell chemistry. How to select a good battery? You see, there are many kind of battery, and this is the spider chart. Spider chart consists of specific energy, specific power, safety, performance, lifespan, and cost. So different type of lithium ion battery has different type of performance considering different parameter. So according to your requirement, you have to choose the battery, which battery you want to take. Correct. So this is a spider chart. So this is the completely OEM responsibility which battery they will take. Then another thing is battery swapping technology. For battery swapping also, you have to standardize the battery amongst all OEM. Suppose Tata Motor and Ashok Leyland, one customer is Tata Motor vehicle, or other customer is Ashok Leyland vehicle. So the battery should be standardized so that they can be swapped with each other. So for that, government and different OEMs should come together to make this available. Then investment required. You can say now all OEMs are going forward for the investment. Government is also investing on that, and government is providing discount. Means through FAM, it is providing discount. If you go for EV vehicle, you will be charged only 5% tax. But for ICE engine, you will be going for 18%. Now 18%. Before that, it was 28%. Then if you go beyond 1500 cc, you will be charged more than 40%. So government is already doing that, less taxes. Then second is customer sentiment. Still, customer is thinking that range is an issue, initial cost is an issue. So these are the challenges. Then thermal safety. You must have seen many news that Ola scooter has burned, many PV vehicle, passenger vehicle was burned. So that is the thermal issue. These are the challenges. For that, we have developed, for Tata Motors, you have never seen such incident. For Tata Motors, we have developed good thermal management system that take care of the heat by traction cooling system as well as battery cooling system. We have a very automated system developed for this, and with this we are managing the thermal part of it. And these are the way forward. In Tata Motor, we have launched passenger vehicle, bus, then different high premium passenger vehicles and small commercial vehicle that we have implemented and launched it. And this will be the next EV vehicle that we will be launching. This will be called Avinya. We have already showcased in this vehicle in Auto Expo. We are going to launch this. Then till now we have discussed the electric vehicle, general electric vehicle, but it is more important to adopt the EV vehicle, electric vehicle in commercial business, means big trucks. Electrification of trucks is more important than electrifying two-wheeler and four-wheeler. Why I am saying this? If we'll see this graph, please concentrate on this graph only. If you see this graph, then the share of truck in comparison to total vehicle running on Indian road is only 3%. Only 3%. And 97% is other vehicle, four-wheeler, three-wheeler, two-wheeler, like that. But despite of contributing only 3%, it is contributing 53% of the total particulate matter. 53% of the total particulate matter and 34% of the total CO2. So, in short, in nutshell, you can say that trucks are contributing most to the pollution. So, it is more important to electrifying the giants. Giants mean trucks. It is more important. So, this is the CO2 emission reduction graph that we are anticipating what will happen till 2050. And if you see the market share, Tata Motor has more than 50% market share in heavy commercial vehicle. Then next is Ashok Leyland 23%, then Volvo Eicher, it is 14%, and others are 12%, Mahindra and other players. So To change the complete scenario, means to reduce the CO2 and NOx emission, Tata Motor plays an important role, and that is what we are doing. We are the first organization in India to move towards electrification in heavy commercial vehicle. Similarly, you can see this is another graph. Means if by 2050 we'll do electrification in heavy commercial vehicle, we'll be saving 9.6 million 9.6 million EV trucks will be on the ground, and which will reduce the 2.8 gigatons of CO2 emissions, which will be equivalent to 46 billion tree plant. So you can see the impact, 46 billion tree. And likewise, this will be the effect on particulate matter and NOx. And please concentrate here. There is a say that electric vehicle are more costly, so people are not buying electric vehicle. So I have given a comparison for 2025. For example, this many data are factual and some data are imagined. Please concentrate on this table. Now the SCV running on Indian roads are 40 lakh, and average distance per truck per kilometer is 80,000, and fuel efficiency is 3. This is average fuel efficiency of truck. But if it is a small truck, it goes up to 4 kilometer per liter, and if it is a big truck, means 55 ton, it is even less than 2. So average efficiency I have considered 3 kilometer. And energy consumption, that is electric, if I'll adopt electric vehicle, then it is only 1.2 kilowatt hour per kilometer. It consumes 1.2 kilowatt hour per kilometer. So diesel consumption per truck is this much, and total diesel consumption in billion liters per truck is this much. Can you imagine? We are consuming 106.7 billion liter per year. And if you will consider the calorific value of diesel, that is 36 megajoule, that is 10 kilowatt hour, then this is 1067 terawatt hour per year. And with this calculation, so total energy we will be saving is 64%. So the EV is 64% more efficient than that of internal combustion engine. This is the calculation. Then we have discussed this driving innovation in EV. Then challenges also we have discussed, that is high upfront cost, inadequate charging infrastructure, regulatory hurdles, range anxiety. And then some of the suggestions how to do faster integration of EV. Successful EV deployment, operational feasibility, public-private partnership, and air quality impact. And this is the plan for scaling up EV adaptation. And you can see we have made two type of electric vehicle. One is Prima 55 tonner tractor that already we have provided to Tata Steel. And these are some photographs when we launched this in March 2024. This is TV Narendran, MD of Tata Group. This is TV Narendran, MD of Tata Steel. Then Girish Bagh, our MD, our CTO. With their presence, we handed over some electric vehicle to our customer. That's it. Do you have any query regarding electric vehicle till now? Hello? Am I audible?
Yes, yes, yes.
If anybody have any query, you can ask me, because after that we will be moving to LNG and advanced system in quality.
Sir, one question I want to ask.
Yes.
We are just you told that we are moving to the electrification of heavy vehicles. So to reduce the CO2 and NOx emission.
Correct.
So, what about the production of electricity using the coal or any other factor that also contribute CO2 and NOx to the environment?
True.
So how it will be impactful, helpful to the environment?
See, there is a three way how it will be helpful. One is efficiency of internal combustion engine is only 18 to 25%. Okay.
Yes.
Efficiency of electric motor is more than 90%.
Yes. Yes.
Okay. So if you will consider the efficiency, then electric vehicle are more efficient. Coming to the second point, if I am running a vehicle on diesel or petrol, then there is no doubt I am burning fossil fuel. It is 100% I am burning fossil fuel, right?
Yes. Yes. Yes.
But if I am using the electric vehicle, then the source of electricity can be green, it cannot be green. If I am burning coal for generating electricity, then in that case it is contributing to the pollution. But
Yes. Yes.
if I am generating electricity by green means like wind energy
Or we can say
and
nuclear,
hydraulic power plant, water,
nuclear
water
energy,
sources, tide,
nuclear power plant.
nuclear power plant,
Yes.
renewable sources, then the source of
Yes.
electricity is green. So here you have a chance that you are not using, not causing pollution to the environment.
Yes, sir.
But in internal combustion engine using diesel and petrol, there is 100% chance that you are doing pollution only.
Yes, sir.
Correct?
Yes,
Then
sir.
third is tailpipe emission. I have told 2
Okay.
points. The third point is tailpipe emission. Generally, power plant are located away from habitats, right? Where more
Yes.
population is there, power plant are not established there generally. But it is a different fact that once power plant is established at somewhere, then people go there and make their houses there. That is a different thing.
Yes. Yes.
But initial stage, power plant are established away from the
From
habitat,
the city,
habitats. So
residential.
whatever
Yes.
pollution it is doing at that localized area.
Yes.
But electric vehicle as such is not doing any pollution.
Yeah. Yeah.
Correct. If I am
Yes.
if I am running a electric vehicle in a town, suppose 100% vehicles are electric in Delhi. For example, 100%
Yes. Yes.
vehicles are electric in Delhi. Then at
Uh,
Delhi, if you consider only Delhi location, it will not do any pollution.
yes, sir. That's a very important point. Yes, sir.
And that is called tailpipe emission. So in electric vehicle,
Yes, sir.
tailpipe emission will not be there.
Okay.
Okay,
Yes.
so that is the three basic
Yeah.
reason to adopt electricity.
Yes. Thank you, sir.
Okay. If anyone has any other query, then you can please ask.
Hello, sir.
Sudhanshu ji, yes, good evening. Sudhanshu ji, you are saying something, but you are not audible.
Yes. Hello, yes, sir. Am I audible now?
Yes, you are audible.
Sir, like petrol vehicles, there is a duration that it can run on road for 15 or 20 years based on the RTO they have permission they have given. So does
Yes.
EV vehicles, they have a specific duration of the battery, like 7 or 8 years, it has to be changed or replaced, or it can run for the same duration as petrol vehicle from 15 to 20 years without any replacement of components?
See, one thing is government mandate. Why government impose a mandate? Because we are migrating to different pollution norms from BS1 to BS2 to BS3, BS4, BS5, BS6. Now we are at BS6. Correct?
Yes, sir.
And how these pollution norms are decided? It is based on two things. One is particulate matter, NOx, and CO2 emission. Basically, three things. Particulate matter, that is the soot particle we are emitting to the environment. Then CO2, then NOx. If you will compare this pollution of BS6 vehicle with comparison to its previous one, means BS4 or BS3, then BS4 vehicle will be causing less pollution in compared to BS3 or BS2. So based on that, government is imposing those rules that after 15 years we cannot be running the old vehicles to control the pollution. Then second parameter is reliability life. Reliability life is without any defect or without any failure for how many kilometers the vehicle can run of its own. That is reliability life. You must have read about B10 life, B15 life, B50 life. B10 life
Yes.
is 10% of failure will happen till how many kilometer or how many of life of that component. So reliability life will based on the beaten life that we calculate. So you are coming to the life of electric vehicle. Whatever trend we have now and whatever data we have received from field till now, whatever passenger vehicle we have provided to vehicle and whatever data we are getting from field, based on that we are calculating that life of battery will be 6 years to 7 years. After that you have to replace those batteries, because it has a limitation that for how many cycles you can do it full charging. Even if in mobile charger, if you consider a mobile charger, it has also a life. Means mobile charger means, sorry, in battery, mobile battery, it has also a life for how many times you can charge it. Same thing for electric vehicle. You can charge it 300 cycles, 400 cycles, 500 cycles based on the capacity. For example, in Tata Motor we have two type of battery. One is 300 kilowatt hour, second one is 450 kilowatt hour. So both batteries different charging cycles and range accordingly as per our requirement. So basically the life of vehicle will depend upon the reliability life. Second is the mandate. But for electric vehicles, since there is no pollution, so I think there will be no mandate by government to replace those vehicle in 5 years or 10 years,
Okay, sir.
because it is not causing any pollution. So there will be no mandate from government. It will depend upon the only reliability life.
Okay, sir. Yes, thank you, sir.
Yes.
Hello, sir.
Yes, Biswajit ji, please.
Good evening, sir. I have
Good
just
evening,
one
sir.
query that,
Yes.
like in four-wheelers, we are using hybrid vehicles. That is, along with battery, we are going for IC engine combination.
Yes.
Are we
Yes, sir.
using this same thing in heavy vehicles, like you are producing, sir? Any? So far?
Sir, till now, if you consider the heavy vehicles, see, in heavy vehicles depend when a customer will buy our vehicle, when he will get a profit. The market scenario of passenger vehicle and commercial vehicle is totally different. Just when a customer buys a trucks, what is in his mind, his or her mind, I will make some profit. That is why I'm buying this truck. If I'll include the hybrid technology, means I will put ICE, then EV, both options, then the cost of truck will go very high. It is not that technology is not available. Technology is available and it can be done. But the initial cost of truck will go very high. And
And my
secondly,
question is, sir, my question is whether when there is the demand for this or the need for this or not. That's your
no,
that's
no, sir. There is no need. We have technology
only
available, but we
BEV
are
is
not
doing.
selling. Yes, yes.
Only BEV is doing. And thank you, sir. That's my
We can do it. And secondly, suppose you are adding both EV technology and internal combustion engine to the same truck, then the weight of truck will be very high.
Definitely, that's definitely.
So if weight of truck will be very high, then payload will decrease, because government has a mandate. Suppose a truck is 49 ton. Out of 49 ton, 22 ton is the weight of truck itself. So the payload that customer will carrying the load, that is 49 minus 22, right?
Yes, sir.
That is the payload. For that payload, the truck driver or truck owner will be getting the money.
Yes.
If I will add
Yes.
both battery as well as engine, then the weight of truck itself will go high. So payload will decrease. So that is why it is not advisable to bring both technology in truck segment at least.
Thank you very much, sir.
Yes, yes. If anyone doesn't have any query, then we can move to next chapter, next advancement in quality. Should we move?
Yes, yes, you can move.
Yes, yes. Thank you. Then coming to next technology, that is LNG. Basically, this is LNG plus CNG, and if you see, then LNG and CNG has no difference. The composition of LNG and CNG both are same, that is methane, CH4. It is LNG and CNG differentiation is only thing is that how we are storing it. For CNG, that is compressed natural gas, we are storing methane in high pressure, 300 to 400 bar. But in LNG, that is liquefied natural gas, we are storing it at minus 162, 63 degrees centigrade. So that is the only difference between LNG and CNG. How we are storing it, but chemical composition are same for LNG and CNG. So we have two technology, one is LNG and CNG. I am explaining the LNG technology, and during this I will cover CNG also. In LNG, we are using the cryogenic tank. This is the cryogenic tank. 2, 3 as per the vehicle requirement we are using it. In cryogenic tank, there is super wool between the two. In this tank, super wool is used, which can maintain the temperature of a gas at minus 163 degrees centigrade. So it is liquefied natural gas. The fuel will be stored in liquid form, and pressure will be 16 bar. Now we have increased it into 24 bar. Then from this tank, the liquid fuel will go to this heat exchanger. In heat exchanger, the liquid natural gas will be transformed to gaseous stage in heat exchanger. And after this heat exchanger, the circuit is same for LNG and CNG, because CNG is only the gaseous form of LNG. So from heat exchanger, there will be solenoid valve with low temperature sensor. Then it will go to fuel filter assembly. Then it will go to pressure regulator, from pressure regulator to engine. This is the circuit of LNG system. And for CNG, you remove this LNG tank and fit a CNG tank and remove the heat exchanger. Circuit is same, basically. So LNG or CNG also, this technology also available in Tata Motor, and also all the OEMs have this technology available. But availability is still is an issue in India. Infrastructures are not available, so people are not adopting it. But it is a good technology, and we are ready for this technology for LNG and CNG. If anyone has any concern in LNG, then you can ask. Otherwise, we'll move to advanced quality systems.
Good evening, sir.
Good evening.
Let me know that how the LNG is being stored to maintain at minus 160 degrees centigrade. What about the energy which is required for making this liquid?
See, we are only storing it in 163 degrees centigrade, but no external heat engine is attached to this tank. So at the filling station, the temperature of this fuel is maintained to minus 163 degrees centigrade at the filling station, and that fuel is filled in liquefied form only. And since this cryogenic tank is a very special tank, and it is using the super wool. Actually, its construction and everything is available with me, but I cannot expose them because it has this is a very proprietary design, and I cannot reveal those technologies. But it has a super wool between the two layer, which maintains this temperature 163 degrees centigrade. But there are losses, fuel losses are there. I have not explained it. Now I am explaining, since you asked this question. There is the vent line, you can see.
So that means the tanks of LNG and CNG are different.
Correct. In CNG, it is a high pressure tank. It can maintain the pressure up to 300 to 400 bar. But the LNG pressure is very less, only 16 bar. But it has to act as an insulated tank, so that this temperature loss will not happen.
Okay. Either way, we have to half guard the control.
Either way, we have to
half guard the liquefied gas. That either we have to increase the pressure or decrease the temperature.
Decrease the temperature. Yes, correct. See, if I will not do it now, then my size of fuel tank will be very high.
Yes, of course.
Because it is a gaseous form. Natural gas is a gaseous form. Then complete truck will be filled with I will be carrying a big fuel tank in my truck.
Yeah.
So get that volumetric efficiency, either I have to store the fuel in a very high pressure or a very low temperature. That is the only thing I have.
Right.
As a truck designer, I can do either this or this.
Okay.
So that is the way to store the natural gas. So this is the technology. Otherwise, engine are same. Everything are same. But in diesel engine, we are using compressor ignition. In LNG and CNG, we are using spark ignition. That is the difference.
Okay, just like petrol vehicles.
Just like petrol vehicle. Yes, correct.
Okay, thank you, sir.
Thank you. So should we move to the next chapter?
Yes, sir. Yes.
Yes. Thank you. Next chapter is digital foundation. Yes, digital foundation for reliability assurance and integrated approach. Actually, this whatever I will be explaining now, this is actually presentation form of a technical paper that we have presented in ANQ Yokohama last year, and this was one of the only 5 papers selected from India. ANQ is Asian Network of Quality. Total 20 institutions are part of this Asian institution, and only very few papers are selected in ANQ, out of which this paper was selected, and we have presented in Yokohama last year, this paper. Before going to the paper, for basic, I will explain what is IPTV, what is reliability planning, and what is DFMA. IPTV is incidence per 1000 vehicle. We are using, not only Tata Motor is using IPTV. IPTV is used everywhere in all industries. Suppose I am selling 1000 vehicle. Out of 1000 vehicle, how many vehicle have defect in the field? Means customer has reported how many concerns in those 1000 vehicle. That is IPTV. It is incidence per 1000 vehicle. In denominator there will be 1000. And IPTV is calculated 3 MIS, 6 MIS, 12 MIS, 36 MIS. What is 3 MIS? MIS is month in service. For example, if I am selling a vehicle in August, if I sold 1000 vehicle in August, 1000 vehicle in August, then in September, October, and November, in 3 months, how many defects are reported in those 1000 vehicle? That is 3 MIS, 3 month in service. It is called IPTV, 3 MIS. After running those 1000 vehicle for 6 months, then it will be 6 MIS. If it is run for 9 months, it is 9 MIS. 12 months, then 12 MIS. Up to we capture the data till 48 MIS. Means 4 years. Whatever vehicle will sell in field, we capture the data for 4 years. That is 48 MIS. That is called IPTV. And not only Tata Motor does this, every OEM, every automotive OEM does this. It is the only mean to capture the field failure. It is called IPTV, incidents per 1000 vehicle. Then what is reliability planning? I have already told that B10 life, B15 life, that I have already told this is the reliability planning. Reliability planning is before launching any new product, we do plan what will be the life of that product and what kind of IPTV we will be getting in future. So that is called reliability planning. We have many formula to calculate the reliability life of a product or a component or a child part. We have established formula at Tata Motors for calculating that reliability planning. Means what will be the reliability life. To explain in the simple term, in home you must have seen for LED bulbs. If the warranty period or guarantee period is 2 years, if you see, once the 2 year is completed, after 1 month or 2 months, that bulb will get fused. But earlier it was not happening. Nowadays it is happening. Suppose the manufacturer has provided you that warranty period is 2 year. After 2 year, 1 month or 2 year, 2 month, the bulb will fuse. So that is the optimization of reliability planning. Means during development of that product, the manufacturer knows till what time my product will survive in the market. So based on that, here that manufacturer provides a warranty period. So that is why reliability planning is required. Then coming to DFMEA. Many of you must be knowing what is DFMEA. It is design failure mode and effect analysis. Since I'm working in research and development department, we do DFMEA for every product, every component we do DFMEA. And sorry, I have written it. Why DFMEA is used? It is an analytical technique to assess the risk. It is a structured group activity which is used for identify the potential failure mode and its causes identify and prioritize the control action, then document the process. DFMEA concept is basically taken from the aviation industry. In aviation industry, there is no chances of failure. If there is a failure, then everybody will die, in aviation industry. And in rocket industry also same. You don't have liberty to pass on a single defect. You must have heard about that one prestigious program, means it was failed because of bad quality of a washer, single washer. Similarly, the recent mishap in Air India, the analysis is coming that somebody has switched off the fuel supplier. Accidentally it was done, or due to any technical malfunction, the fuel supply was off. So thing is that you cannot, you don't have liberty to cater a single defect in aviation industry. That is why DFMEA is very important in aviation industry, and automotive industry has adopted DFMEA from aviation industry. It is the concept DFMEA. So how DFMEA is done? This is the DFMEA sheet. Actually, there are many prerequisites to DFMEA. It is a very long process. I will not explain that because it is already 7. It is already 1 hour is gone. So in DFMEA, what we do? First, we will write the function of a component. Suppose is seat. Seat, what is the function of seat? We write down here. Then requirement of a seat. Then potential failure mode. What is the potential failure mode? What can go wrong? No function, partial or over a degraded function, intermediate function, or unintended function. And there is a standardized tools to how to identify this. Means, see, just there is a pre-DFMA documents are there. You have to use product structure T, then item function requirement, boundary diagram, parameter diagram, and robustly sheet. There are ways and means how to identify these failure modes during design. You can see that we adopt. Then coming to whatever failure mode we have identified, we note the severity of those failure mode. What should be the severity? Then what is the causes of those failure? What design prevention actions we can take? Then what kind of design detection we can take? And what will be the recommendation action? So whatever we are designing for component, for subcomponent, for assembly level, for vehicle level, we do this DFMEA, and after completion of this DFMEA, we only launch the product. And whatever detection control we mention here, we do a rigorous validation of the part and vehicle. These are the advanced tools. This is the advanced tool used in quality systems. So in DFMEA, if you will see, to prioritize the actions, one is severity, one is occurrence, one is detection. Severity is how severe that problem is. Occurrence is how many times that problem may occur. And detection is how strong is my detection system. Means it should not pass on to the next stage or to my customer or validation stage. So based on that, detection ranking is given. There is standards how, and after multiplying the severity, occurrence, and detection, you will get a RPN number. RPN number is risk priority number. This is risk priority number, and risk priority number provide the priority to that particular failure mode. See, there is a scale for all these three: severity, occurrence, detection. The scale starts from 1 to 10. So maximum it can be 10, minimum it can be 1. So multiplication of these three will be maximum 1000. See, here an example I have cited. Suppose one failure mode A, one failure mode B. Severity is 9, occurrence is 2, and detection is 5. Then RPN number will be 90. For failure mode B, severity is 7, occurrence is 4, detection is 4. RPN number will be 112. And there is a table how to rank the severity. Suppose one failure, it affects the safety of the operation, vehicle operation, and it is non-compliance with the government regulation, then severity will be 10. If it is without warning, then severity will be 10. If it is with warning, then severity will be 9. Accordingly, this ranking is decided. Similarly, for occurrence, if the defect may occur 100 per 1000, then ranking will be 10. If it is only 1, means 0.001 per 1000, then ranking will be 2. Lesser is better. Here also lesser is better. Then coming to detection, then detection same. So this is multiplication of severity, occurrence, and detection as RPN number. Based on RPN number, we have to prioritize the action and take the action. Take the prevention action as well as design action. Then these are the basics. Then coming to this unified architecture. These are the objectives that we wanted to launch the first time right, every time right, and customer delight product. Then we want to integrate the artificial intelligence into the quality system. Then finally, we should get the customer peace of mind. That is our ultimate goal. So before that, what was the problem? Tata Motors field failure was very high. Our customers are unhappy. Our market share was means decreased to 39%. Then this was the problem. Then systems are isolated, means there are multiple systems in Tata Motors. They were not talking to each other. Means there was no unified architecture. So that was causing delay in validation and new product launch. In automotive sector, the more you launch the new product, your market share will increase because customer will adopt the new technology. So because of disengaged different departments, our quality systems was not good. And due to high warranty cost, the product cost was also increasing. So this was the problem. Basically, disconnected system and conventional system. There was no industry 4.0. So what we did, we standardized the process. Why standardization is required? Currently, everybody is using artificial intelligence. But one demerits of artificial intelligence is it is a garbage in and garbage out process. Whatever prompt you will provide to AI, whatever the database AI is using for calculating or using the algorithm, similar kind of response artificial intelligence will give. If suppose artificial intelligence is using its algorithm from a database, and in the database 100 people has written sun rises in the west, correct? 100 people has given a prompt that sun rises in the west, so accordingly artificial intelligence will give it output. So that is the one demerit of artificial intelligence. If polarization of data will happen, then artificial intelligence will give you wrong prompt, wrong answer. That is why standardization of processes are required. Since we are we have standardized the DFMA process, and we ensure that this has been standardized across all the functions. So this is the standardization and digitalization of DFMA process we discussed. DFMA I discussed. Then what is the input to the DFMA? That is IDT, indoor testing, ODT, outdoor testing, and CAE, computer aided engineering. This is the digital validation system for each and every component. So these are the inputs like IPTV I told, then third party reports. They are inputs for DFMA, and based on the DFMA, we take the action based on the RPN number. If risk priority number is more than 63 and severity is 9 and 10, then we have to take a design action. They are the process we included. I'm not going much into this process because you'll not understand this, because many terms are very specific to Tata Motors, and it will make confusion basically. Then these are the process flow diagram, how we have standardized and digitalized this process. And then this is coming to the action part. Suppose we get one concern that we have a CIB system, critical issue voucher. We raise this issue in CIB system. Then we go to champion, then developer, then part provider, validator, then production part provider. Based on the validation and closure, we close the issue in this workflow. Then this is the unified architecture we developed at Tata Motors. If you see, you please concentrate on this diagram. The input to the foundation DFME is field learning. Whatever vehicle we have launched in the past, we learn from those defects, and whatever failure mode and failure causes we get from this, that was included in the DFME. Then for new technology, like for EV, H2ICE, LNG, CNG, we benchmark the product, we go to the market, go to our competitors, different technical paper written on it, and whatever knowledge base we have, based on that we identify the failure modes and include in those foundation DFMA. And past design learnings, and during validation, whatever concern we get, means during validation and before launching the vehicle, we do extend validation. We run the vehicle for 4 lakh kilometer, 5 lakh kilometer, we run the vehicle, and whatever is issue we get during validation process, we get those corrected in our design and production. Then only we launch the vehicle. So whatever issue we get during the validation, those also come to foundation DFMA. From foundation DFMA, we just digitalized those foundation DFMA to eDFMA. Then from eDFMA, we raise the issues in CIB, where RPN number is more than 63 and severity is 9 and 10. Then it goes to PLM. PLM is product life cycle management. Product life cycle management. For designing a part or product, we use this PLM. Then PFMA. This DFMA is design failure mode and effect analysis. PFMA is process failure mode and effect analysis. During manufacturing process of a vehicle or a part, PFMA is used, and the output of PFMA goes to control plan. See, the arrow is from PFMA to control plan. Control plan is the real check sheet which to be used during production. It is a tick type of thing, whether torque is provided, right torque is provided, whether right sequence been followed, whether right process is being followed. That comes to control plan. Then RMDVB is a validation tool. It is an online validation tool where the designer puts its validation requirement, accordingly validations are done. So this is the process. This is the unified architecture we developed, so that each and every function, each and every process can talk to each other, and there is a closed looping process. After this unified architecture, we implemented this artificial intelligence to the system. How we implemented this artificial intelligence? First thing is the building knowledge repository that I explained in that last slide. Then we used artificial intelligence without the breach of data security. We didn't want to share our data with the AI service provider. That is the most important thing. We have developed our chatbot locally at Tata Motors, so that data will not be shared with ChatGPT, means OpenAI or Perplexity. There are many AI service provider. Once we developed it in-house, and what is the output of this AI? Now you don't have to ponder for data. Means data are in silos. You don't have to go to the silos and ask each and every department. You just ask the AI, what is the issue in X platform for Y aggregate, issue of X component fitting on Y aggregate in Z platform, issue with severity higher than 3 on X model in Y platform. Whatever you ask, suppose you can ask whatever issues we faced in thermal management in electric vehicle, you will get the response from the past defect history, and it will provide the solutions also. In past, whatever actions we have taken to uh, to take a countermeasure on those defect, those data will be displayed. So it will be very handy and easy for the designer to take the actions. So these are the benefit. Reduction in field failure. This is actually 2025. It is wrongly in hurry. It is 73% field failure was reduced. Then first time right, every time right, and customer delight product used. Whatever new product we are launching, defects are very less, and cost of poor quality reduced by 78%. Then productivity was improved, and cost learning between engineering and manufacturing. And intangible benefit, during this process we have applied for 6 patents from Tata Motors, and we got all the 6 patents. Then market penetration was increased. Now we have more than 50% market penetration. Increase the brand value. There are some the intangible benefit. That is why I discussed unified architecture, then positive customer output, and journey ahead is now we want to horizontal deploy it in the manufacturing process. So with this, advanced quality tool is finished. If anybody has any questions, please ask. I think many will have many doubt regarding DFME because it is a very advanced tool and we are practically using it. So you
Participants
can
can
ask.
ask questions.
Yes, yes. If there is no question now, we can move to next.
Yes, sir. You move. You can move.
Okay, okay. Thank you. And after this, now whatever I will be covering, actually that is for students actually. So what should they learn during their engineering period, so that they will be future ready. Basically, when we are recruiting in ZT or PGET from engineering college, we see they lack in some basic tools and techniques. Those are not part of their curriculum. Yes, those are not part of their curriculum, and it can be learned. These are very simple tools that those can be learned in their engineering time, so that they will be future ready and it will be easy for us to adopt them in the industry. But before that, I have already explained this tool. This is a very easy tool, means how they should pursue their life. It is a very easy theory to remember. Three balls theory: eyeballs, fireball, and snowball. I have put this in this way because it will be easy to remember and they will remember it for lifetime. Eyeball, fireball, and snowball. These are the three balls for success. This for student. Generally, we have two eyeballs. Okay. So keep one eyeball in the present. Whatever you are doing. Suppose you are in the first year of engineering or first year of your PG program. Keep that eyeball there. That what I am doing. Keep the second eyeball in the future, where you want to go after 10 year or 15 year or 20 year. So you have two eyeball, one eyeball in the present, second eyeball in the future, where you want to go. So once you have fixed your goal, you will find that what is the gap. I mean, what I require to reach to the second eyeball. So please differentiate those. How means how you will navigate that path? You can navigate that path through education, exposure, and experience. There are three things: education, exposure, and experience. With these three, E3, you can only move from one eyeball to another ball. Coming to education, actually education is abundantly available, and means in Google, in LinkedIn, there are many university, many courses are available. So it is abundant. So you have to decide how much to learn, then from where to learn and what to learn. That you have to decide. That is very important. मुझे क्या पढ़ना है, कितना पढ़ना है और कहाँ से पढ़ना है. That you have to decide based on to where you want to go. If I want to become a UPSC officer, then accordingly I have to set my education, exposure, and experience. If I want to be a professor, then accordingly I have to set my education, exposure, and experience. But please write it down somewhere. In education, what I have to do; in exposure, what I have to do; in experience, what I have to do. E3. Make a sheet and please do it. Then coming to fireball. Fireball is the means what you can see, the zeals, the ambition, the aim that is within you, that I have to do it. To keep your fireball burning, what you have to do, you have to be with like-minded people. Means whoever shares your ambition. Suppose out of 100 friends, 3 or 4 has the ambition of becoming a UPSC officer or IAS officer. Then you please make a group of your like-minded people, so that each one of you each one of you will motivate each other. कुछ दिन में वो आग ना सबसे बड़ा प्रॉब्लम होता है, वो आग ना बुझ जाता है. मोटिवेट लोग मोटिवेशन हो जाता मोटिवेट हो जाते हैं कि आई विल डू दिस डू दैट, बट विथ टाइम इट सप्रेसेस. So it is more important to keep that fire burning inside you. For that, you please be with like-minded people. It is told that you are as good as your friends. If you have a good friend circle, if you have a good environment, then you will be like that only. So for keep that fireball burning, you have to be with good company, basically. Then third ball is snowball. What is snowball? If you see a snow running from a mountain, rolling from a mountain, initially it is very small nucleation point, very small. Once it started rolling down the mountain, the size of snow gets bigger and bigger because it attracts more snow, and it becomes bigger in size. So why I put this snowball? Suppose you want to start a good thing, start it small, keep practicing it, keep practicing it. If you will see the effect will be substantially high after some days of practicing. For example, suppose I want to run a full marathon, 42-kilometer marathon. Then I will start with 5 kilometer, 1 kilometer, 2 kilometer, for 5 kilometer. For 5 kilometer, I will do it once continue. I will continue to do it. Then after that, I will go for 10 kilometer. Then after I will go for 21 kilometer half marathon. Then I will go to 42 marathon. But more important thing is keep it doing regularly. That is why snowball. Start from slow, then keep it doing, so that you will gather masses and the result will be substantially high. So three ball concept, I hope you will remember it, and accordingly you will make your education, exposure and experience. So it will help. Then coming to tools, what tools will make you future ready for the industry? First, go for project management course. It is a very means 1 month, 2 months, 2 month course, easily available. You can get it online, but please do it, because in industry everything is project management. Suppose I am going to launch a new product, it is a project management. In you go to software industry, you go to mechanical industry, you go to electrical industry, project management will help you. So please do a project management course. Then Six Sigma problem solving. In Six Sigma, there are many belts, means white belt, yellow belt, green belt, black belt, then master black belt. After that, PGDQM course is there, postgraduate diploma in quality management. So please do some Six Sigma courses. It will be helpful. Irrespective of which function you are going, you may be working in research and development, you may be working in operations, you may be working in planning, HCM, any department. But Six Sigma problem solving will help you. Even this tool will help you in your life also. So please do this Six Sigma problem solving tool. Then AI, ML, it goes without saying, because this is the age of artificial intelligence. We are using artificial intelligence in everywhere. Everywhere. If you come to Tata Motor, every department is using artificial intelligence. Like I said in the last presentation, no, we use artificial intelligence for capturing the field issues and horizontally deploying the learnings from our past effect history. Then coming to understanding and analyzing the data. Nowadays, data is gold. If you see OpenAI, what it is using, it is just using an algorithm, but the base is data. It is taking data from internet and using some algorithm to give the prompt response. So understanding and analyzing data is more important. Then advanced Excel and Power BI, please go for it. If, throughout your life, you will be working in advanced Excel and Power BI. It will be useful. PPT, advanced Excel and Power BI. Please get this tool. Please learn this tool. It will be very handy for you while working in the organization. Please learn this tool. It is my sincere request. Please learn this tool. It will be helpful for you. Then coming to some self-helping tools. See, I have explained in one of the session last time, but it was limited to for only mechanical first year student. I will repeat it. In your life, no, whatever task you are getting, please distribute those tasks to this 4 quadrant: urgent, not urgent, important, not important. So in this 4 quadrant, if the task is important and urgent, please do it. If it is important but not urgent, please schedule it. If it is urgent and not important, delegate it. If it is not urgent and not important, please don't do it. Don't waste your time in that. So please prioritize your work. Means what type of work is urgent, and means prioritize the work based on the urgency and importance, and do it. Because in corporate life, the work pressure will be huge. There will be multiple tasks and you will not able to complete the task 100% sure. So you have to prioritize those tasks. So based on this, as an our matrix, you have to prioritize your work. This is one thing. Second one is SWOT analysis. Generally we do SWOT analysis for a department, for industry. What is SWOT analysis? S is strength, W is weakness, O is opportunity, then T is threats. So I will advise you, please do your SWOT analysis. For individual SWOT analysis, please identify your strength, identify your weakness, identify what opportunities you have in future, and what are the threats. Out of these four, the strength and weakness are your internal, but opportunity and threats are external. These two are under your area of influence, but this opportunity and threats are beyond your area of influence. You don't have any control on opportunities and threat, but you have control on strength and weakness. So based on your strength and weakness, you can cater your opportunities and threats. So please identify it. Take help of your friends, take help of your mentor, take help of your teachers to identify this. But it is more important to identify what is your strength, what is your weakness. So convert your weakness to your strength and convert the threats into your opportunity. That is more important. But more important is, please do a SWOT analysis for yourself. Once you will do the SWOT analysis with the help of yourself, your friends or teachers, then you will be open to Johari window. What is Johari window? You know, see, Johari window is, you know about you, but you don't know many thing about you, but your friend knows about you. There will be many things that you also don't know about you, your friend also don't know about you. Like that, Johari window is another tool. You please search in the Google, you will get what is Johari window. Then I will recommend two books for you. For students, I will recommend two books. Even teachers and professors can also read. One is Seven Habits of Highly Effective People. It is a very good book, easy to practice, and it will help you. It is one of the bestseller, internationally bestseller book. In what are the seven habits? One is be proactive, means avoid procrastination. Then the most important habit out of these seven is begin with end in your mind. Whatever you are doing, please ask yourself what I am going to get at the end of it. Begin with end in your mind. Means I told about two eyeball concept, no? Where I am right now and where I want to go after 5 years or 10 years. So begin with end in your mind. Then put fast, think fast, think win-win, seek fast to understand, then to understood, synergize, sharpen the saw. They are the seven tools. But buy this book, Stephen Covey. It is available in Amazon, Flipkart, everywhere it is available. And this is the second book I will recommend. That is Atomic Habit. I told about the snowballs, no? So Atomic Habit will help you in adopting that snowball. How small habit can create a big impact. This book is about that. So I am recommending you two books. One is Seven Habits of Highly Effective People. Second is Atomic Habit. Once you are done with these two books, then there are many books like The Magic of Thinking Big by Steven Stowe, and then Good to Great by Jim Collins. There are many books are there. But please start with these two books, Seven Habits of Highly Effective People, then Atomic Habit. Then why I'm saying this story, the Chinese bamboo story. Most of you must have heard about Chinese bamboo story. What is Chinese bamboo? It is one of the tallest grass in the world. But the interesting story is, uh, when you will put the seed in the soil and keep on watering, if you water for the and give some fertilizer, you water for the 1 year, nothing will happen. Nothing will happen. You will lose your patience. That for 1 year I have been putting water and taking care of this seed, but nothing is happening. Same thing will happen for third year, for 4 year, for for second year, for third year and 4 year. Means for 4 years you will provide water, fertilizer, soil to the seed, but nothing will come out of the soil. You will get frustrated. But after completion of 4 year, one day we will see some two leaves coming out of the soil. And believe me, in 6 weeks, means in 42 days, the tree will long tree will grow as tall as 80 feet in 6 weeks. 6 week 80 feet. Why I am telling this story? This story is has an analogy to this graph. This graph is called plateau of latent potential. When you want to start your learning curve, when you want to improve yourself, initially you will provide your time and effort, but the result will be not reciprocated at the similar manner. You will provide your, actually this green graph, you will see the green line. That is what you think should happen, that if I will provide the time and effort, result will be accordingly, but it will not happen. For starting 4 year, if you will consider the Chinese bamboo story, for starting 4 year there will be time and effort, but the result will not be substantial. But once you cross this threshold, you will see the substantial growth. Like for the Chinese bamboo story, in 6 to 8 weeks, the tree grows as tall as 80 feet. That is what this graph says about. So, what I'm saying is, don't lose your patience. Don't stop in this valley of disappointment. This is called valley of disappointment, where you will be putting your time and effort, but result will not be substantial. Don't lose your patience. Don't stop here. And believe me, 90% stops here. Don't stop here. Please cross this threshold. Don't be disheartened. One day you will also grow like that Chinese bamboo. That is what I want to say. Then second thing is, see, in life now, the pressure is not going to diminish. Once you are out of the college, you will get married, you will have children, so you will have more responsibility, you will have job, your parents will be growing older, they will have their own disease due to old age, you have to visit hospital frequently, so stress will increase. And it is more important to strike a good balance between work and life, what we call work life balance. It is more important to, just a minute. Hello, hello. I am audible, right?
Yes. Yes.
Okay, okay. So it is more important to strike a balance between work and life. So please pursue a hobby like this. Great man has pursued their hobby. Like APJ Abdul Kalam, he used to play Bina. Then Modi Saab, he has a photography. Lata Mangeshkar, he has photography. Similarly, please pursue a hobby. It will balance yourself. It will reduce your stress. Okay, please. I am just showing my hobby, what I am doing. I have established a museum, the Kalinga Heritage, where more than 10,000 coins and paper monies are available. And it is in Guinness World Record also, Guinness Book of World Records. And these are some of the newspaper that that has covered my collection, some interviews, and this is Guinness Book of World Records. And this hobby is appreciated by a late respected Ratan Tata sir. He has gone through my hobby and appreciated it very greatly. And these are some of the CSR activity I used to go to school and explain my hobby, share the knowledge about hobby. You can see these photographs. Basically, what why I'm showing my hobbies, I'm not glorifying my hobby. I'm just pursuing you. I'm just requesting you to please pursue a hobby. That is more important. And at the last, I will recommend ki make a life statement. The life statement should include vision, mission, education, then hobbies, health, spirituality, relationship, and legacy. What you want to contribute to the society. You please write it down very clearly what you want to do. Then get it signed from your friend or your teacher or your parents, so that it will be documented, and do and proceed in your life accordingly. But please sign a life statement. That is more important. I think we are done, and I have nothing to share more. If anybody has any query, then I think only 1 hour was budgeted, and we crossed.
Oh, no, sir, it is
1 hour and
actually
30
okay.
minutes.
It's okay. Any participants can ask any questions if you have any queries. Okay, I think no queries. Sir has explained very good way. And thank you, Dr. Devavat Gridi, sir, for your information about this automobile Tata Motors and the suggestions that you have given for our students. That will be definitely passed to your students. They will become future ready. So thank you very much, sir. Your information and your insights will be helpful for our participants, and definitely they will utilize your insights in their research work, in their future research work. So thank you very much, sir.
Thank you. Thank you.
Okay, our next speaker is Dr. Apurva Kumar Das. Dr. Apurva Das, okay, sorry, is online. Now we'll move to our next session. Yes, sir.
Yes, sir.
Ajit, make Dr. Apurva Das co-host.
He has already done.
Okay. So Dr. Apurva Das has an assistant profession in Mechanical Engineering Department, IST Sipur. Dr. Das has obtained his BTech degree in 2005 from Haldia Institute of Technology, Haldia, and his master's from Bengal Engineering College, Bengal Engineering and Science University, Sipur, presently known as Indian Institute of Engineering Science and Technology, Sipur. In the specialization of machine design, he earned his PhD from Jadavpur University, Kolkata in the year 2019 in the field of applied mechanics. He has received the university silver medal based on BTech results from West Bengal University of Technology. He has worked as co-investigator of a DST Indo-Japan Cooperative Science Program. He has worked as a research fellow at the School of Environmental and Society, Tokyo Institute of Technology, Tokyo, Japan. He is a life member of Indian Society for Non-Destructive Testing, corporate member of Indian Institution of Engineers, a life member of the Hong Kong Society of Mechanical Engineers and the International Association of Advanced Materials. Dr. Das is involved in several industry and government-sponsored projects. Dr. Das has worked for over 6 years in industry, such as design engineering, including the General Electric Company, Bangalore. He has also served as design manager and general manager design for the French railway company Millet AFR in France. Dr. Das has guided 2 PhD and 8 MTech students. Presently, he is guiding 6 PhD and 2 MTech students. The title of Dr. Das is Aluminum Alloy for Aerospace, Railway and Biomedical Applications. So now I welcome Dr. Das to our Atal FDP. So Apurva sir, you can share your screen and start your presentation.
Thank you, Dr. Raut. Hope my voice is audible.
Yeah, it's audible.
Yeah. Thank you for your illustrative things. So let me share my screen. So hope my screen is visible.
Yeah, it's visible. Make it full screen.
Yeah. Okay.
Yeah, it's okay.
Once again, thank you, Dr. Raut, for your nice introduction and illustrious explanation about me. Though I am trying my level best to work in this field for the last 6-7 years. Okay, so today I am going to present my talk on the aluminum alloy, which is basically generally used in aerospace, railway, and the biomedical application. So without explaining, we can go to the main content. What are the things that I'm going to explain? First, we will check some quick facts about the aluminum, and then classification of the aluminum alloy based on the series. Then aluminum alloy for the aerospace applications, we will see some example. Aluminum alloy for the railway application, we will see some example, also some case studies that I have worked for the various companies. And then aluminum alloy, which can be applied for the biomedical application, not to the exactly to the human implant location, but some other application, because aluminum is not that too much biocompatible compared to the titanium or the location. Then a few experimental results, and we'll see go for the conclusion. Okay, so as we know that aluminum is a lightweight material compared to the steel. It is having a density of 1/3. So that's why its strength to weight ratio is always high. So it is having high specific strength and compared to the steel. So there is a huge advantage of the weight, which is basically a governing parameter for the aerospace industries, because weight is one primary constant for the aerospace industries. Aluminum is also having a very excellent corrosion resistance. It is anodizing friendly, and obviously it is manufactured friendly. It can be manufactured by rolling, extrusion, forging, casting, or some cases additive route. It can be manufactured. It is also weldable. That is one primary aspect of making this metal for any desired structure by cutting, welding, and then fabrication. Aluminum is 100% recyclable, and it is embodied energy advantage, and it is having the very recycled feedstock is very high. So it can be used, and again, once its life is goes, it can be remelted and reused. So that is one big advantage for the aluminum. So aluminum is widely available in our nature, though it is in a form of the bauxite. From this bauxite, the aluminum smelter we can get, and then from there we can get the alumina, and then finally the alumina. So there are a few companies who produce the aluminum worldwide around as well as in India. In India, Hindalco is one of the big company, Nalco, Balco. Those are the big companies, and there are a lot of bauxite mines are available in the Orissa and the Jharkhand region. Okay, so we're coming to the aluminum alloy series. So basically, it is governed it is designated by 4-digit system based on the Aluminum Association, which is a American association society who governs this American association. So the first series, that is the commercially pure aluminum, we call it is the 1 series. It is having greater than 99% pure aluminum. It is excellent corrosion resistance. It is having very good thermal and electrical conductivity. So that's why in power transmission or the power grid lines, 1350 alloy is used, and some cases in the pure form in the aluminum, it is 110, 1100, that is used for the food packaging cases. So let me open my pointer. I have just okay. So 1350, that is a 1 series alloy. It is used for the power transmission because it is having good thermal conductivity and it is having the electrical conductivity. Now, the second category, that is the heat treatable alloy. Heat treatable alloy means we can do the heat treatment, which comes for the 2 series, 6 series, and the 7 series. So 2 series is basically aluminum copper alloy. So copper is the main gradient over here. It is having high strength, lower corrosion resistance, and commonly used in the aerospace because we need high strength, but it is having the lower corrosion resistance. 2024, 2219, these are the alloy it is used. Next is the 6 series alloy. 6 series alloy is aluminum, magnesium, silicon alloy, which is basically the governing, the main ingredient is that magnesium. So it is medium strength. It is having the excellent corrosion resistance, good machinability, weldable, and alloy in this series contain the silicon and magnesium in order to form a magnesium silicate within the alloy. Extrusion product from the 6 series are the first choice for the architectural and the structural application. It is having a wide application in the automotive domain, in the railway domain, like 6061, 6063, 6082. I will explain these things, all these alloy, because these are having a very good application in the railway domain. Next is the 7 series alloy. 7 series alloy is basically zinc is the main ingredient over here, apart from this aluminum, as well as some part of the magnesium and some part of the copper is also used. So zinc is the primary alloying element in this series, and when the magnesium is added in a smaller amount, the result is a heat treatable and very high strength alloy it is. So other elements such as copper and the chromium may also be added in small quantities. It is having very high strength and it is used in aerospace, defense. But one problem is that it is prone to stress corrosion. You can see that we are using the Apple aluminum watch. It is made of this 7 series aluminum alloy. Okay, third one is that non-heat treatable alloy. Non-heat treated alloy are strengthened through the cold working because it cannot be heat treated. So it needs to be strengthened through the cold working. Cold working occurs during the rolling or the forging methods and is the action of the working of the metal to make it stronger, and cold working increases the strength of the metal. Alloying elements such as magnesium, intensity of its effects. In some cases, other elements can be added. So in this category, there are several series are there: 3 series, 4 series, and the 5 series. In 3 series, it is aluminum manganese alloy. It is good corrosion resistance, moderate strength, and commonly used in the roofing or the sliding location. This is generally used. And 4 series is that aluminum silicon. So silicon is the alloying element, main alloying element over here, and added in the sufficient quantities to lower the melting point of the aluminum without producing the brittleness. It is having the good wear resistance, low expansion, used in automotive engine parts like 4032 or 4045 series. Another is the 5 series. 5 series is the aluminum and magnesium alloy. This alloy possesses the moderate and high strength characteristics, as well as it is having the good weldability and resistance to corrosion. It is basically used in the marine application, some cases in the building construction, pressure vessel, this kind of 5 series aluminum alloy is used. Another series, that is 8 series. 8 series is the miscellaneous series. Here aluminum, it is added with the ferrous, silicon or lithium, or some cases you can see that in the packaging location aluminum foil and other locations it is used, but lithium is used for other special applications. Okay, so in a nutshell, these are the series of the aluminum alloy based on their configuration. So first series is a pure aluminum, which is having more than 99% aluminum. Second series is a aluminum copper. Copper is the alloying elements. Third is the magnesium is the alloying element. Fourth is the silicon is the alloying element. Fifth is the magnesium. Sorry, third one is the manganese. Fifth is the magnesium. Sixth is magnesium silicon alloy. It is added with the aluminum. 7 is that zinc is added as a main alloying element. 8 series is the lithium, and 9 series is other alloying element. Some cases we may use. Okay, so this is the just a brief introduction about the different series of the aluminum alloy based on the different alloying elements added to the aluminum, because pure aluminum is not that much is not that much providing that much good strength. It needs to add some alloy, and based on this addition of this alloy, some series are heat treatable and some series are not heat treatable. Depending on the application, we can see what are the series of this alloy is applicable to which sector wise. Okay, so if we see that ratio of the weight percentage for a large commercial aircraft which is presently operating in worldwide, we will see that aluminum consists the majority portion. Like some cases in the Boeing carrier, we can see that Boeing 787, it is aluminum percentage is slightly low, but in other location, the aluminum percentage is almost more than 70%. Comac is a Chinese carrier, which is very is a direct competitor of the Boeing and Airbus. So they are using also aluminum alloy around 65% and the 75%. Airbus is also having more than 75% in that. So you can see that the percentage of the aluminum alloy, it is, you can consider it is weight percentage. Though aluminum is very light, 1/3 of the weight of the steel. So if you consider from the volume percentage, it is going to be again going to be increase. Other carrier like Douglas Aircraft Company, they are also using the same similarly things. So here we can see that the distribution of the different series of the aluminum alloy in the aerospace industries, we can see that 2 series are mostly used. It is something around half percentage of the entire aluminum alloy it is used. Mostly are the 2 series, and then the 7 series like 7075 is also very good one that can be used. Then the 6 series and other series are not that much prominent. So in the aerospace industries, 2 series are widely used. You can consider almost 0.5%, 50%, and the 7 series are used. Okay, so I hope my voice is clear, and please stop me in between if you are having any kind of query, doubt, because I would like to do these things in an interactive mode rather than just I am talking. So I will ask all the participants, and I will request all the participants, if you are having any queries, any anything, you can stop me in between and we can discuss accordingly. So Dr. Raut, I'm just checking it is my voice is...
Yes, sir. It's audible.
Okay, thank you. Okay, so here a typical example for the two carrier, like one is the Boeing, another is the COMAC. COMAC is a Chinese carrier. C919 is the present high grade version, and they are also developing C929 version. And in this Boeing, this is Boeing 787. So here we can see that the upper wing surface and the skin 7055 and T7751 and stringer location 7075 and the chord location 7150. These are the alloy. It is aluminum alloy. It is used in the upper wing surface. This is the upper wing surface, and the lower wing surface is this one. Below the wing, this is the lower wing surface. There the 2 series is basically used. That is 2324 T39, and the stringer location it is 2224 T3511. And the body location, it is obviously it is 2 series it is used. All types of 2 series like 2024, this is used in the body or the skin bones. And body stiffener location, it is keel beam location, it is 7150 and 7155. Body stringer and the upper and the lower lobe, it is 7150 is used. And in the floor and the seat track, like inside of the carrier, it is floor and the seat track, and the stanchions location 7150, 7055, 7150. These are the aluminum alloy are used. Similarly, for the Chinese carrier COMAC, in the C919 model, we can see that a lot of varieties of the aluminum alloy are presently used in the every part of its carrier, be it from the wings, be it from the engine surfaces, be it from the flooring, or in the fuel slag location, or in the undercarriage location, nose, almost all location the aluminum alloys are widely used. So this is the Augusta helicopter. Here a lot of aluminum alloy is also used in order to reduce the weight. Similarly, for the spacecraft or our International Space Station, aluminum alloy are used. Inside of the carrier, the extruded part, beams and frames are made of the aluminum. Okay, so now we can see that there are some advantage of using the different aluminum alloy of the different series. We know that the Young's modulus of the aluminum is not that much high. It is something around 70 GPa. Compared to the steel, it is quite low, almost 1/3. But the strength wise, I mean the ultimate strength or the yield strength, we need to increase significantly to use this alloy for the better structural application. So here you can see that this 2 series, 7 series are having that yield strength is something around more than 400. So that is one primary objective of using the aluminum alloy rather than the pure aluminum. So this is one good example where we can see that Though the Young's modulus of this aluminum is quite low, but still after adding some alloying element, we can increase its ultimate strength and the yield strength, so that this lightweight metal can be used in the aerospace domain without losing its structural integrity. So that is one primary objective of designing any aerospace component for the aerospace industries. Okay, so here, if you see that a typical example of a passenger carrier, where you can see that from every part there are a lot of aluminum alloy are being used. From it's the pilot cabin to the cockpit to the fuselage to the engine to the emergency door location, landing gear, then wing flaps, even in the baggage compartments, which is generally comes below the passenger location. Then horizontal stabilizer, rear door, elevator, rudder, vertical stabilizer, elevator location, horizontal stabilizer, even in the toilets, galleries location, everywhere the aluminum alloys are widely used. The main objective is of using this aluminum alloy is to reduce the tear weight. That means if the tear weight is increases, then obviously the thrust needed to fly is high, the fuel consumption is going to high, and again a lot of aerodynamics effect is going to disturb the motion. So the main objective is just to reduce the weight. So the best available and the best comfortable material is the aluminum alloy. So that's why aluminum alloy are widely used in the aerospace domain. Apart from this aluminum, there are even lighter than aluminum, magnesium alloy is also there, but that magnesium alloy is not that much suitable for the structural integrity point of view or structural strength point of view. So that's why aluminum alloy is widely used in the aerospace domain. So in the aerospace application, the spectrum of the aluminum alloy is used from the 1 series to the 7 series, though the 2 series and the 7 series are widely used. So even in our GSLV rocket launcher location also, we use this aluminum alloy, and we can see that this GSLV, which is recently India has used this GSLV, and a lot of aluminum alloy is used. So we can see that stationary launch vehicle number 3, which was initially operated in 1979. That time, the ratio LEO ratio was 0.27, low Earth orbit, LEO, and ASLV, it was in 1987, that LEO ratio it was 0.35, and then PSLV, which is having the GTO ratio, that is 0.33, and it was operated in the year 1993. GTO is geosynchronous transfer orbit. And then GSLV MK2, which is in operation in 2001, and it is having the ratio of 0.49 GTO ratio. And recently in 2017, GSLV MK3, it is having the GTO ratio is 0.72. And there are a few other parameters are given, like lip top weight, then total height, PL ratio. So those, considering all these parameters, we can see that as the year progress, the technology advances and the ratio is increases. And this ratio is increases because we are using lighter material in by using the aluminum. So this ratio is increasing. Now, I will stop over here for the aluminum application in the aerospace domain, because these applications are wide and there are no end of these things. And there are different categories of the aluminum alloy which needs to be customized based on its application. But one major drawback that in the aluminum alloy, I will explain these things. Just 1 second. As you know that aluminum alloy is not that much capable of withstanding the temperature. So in the aerospace or in the flight, there are two engines are there. So that engines are basically gas turbine. We call it as a aeroderivative gas turbine. So in that location, the inside of the gas turbine, the temperature goes something around 2000 degrees centigrade. So the inside of the engine, we cannot use the aluminum alloy, because aluminum alloy cannot take that much high temperature unless until we are using some coating like alumina or zirconia or some other location. So anyway, we are having some sort of other sort of material which can withstand the high temperature, like Hastex, Nimonic. So in the gas turbine domain, where the high temperature are there we cannot use aluminum alloy. There we need to use some advanced alloy like Hastex, Nimonic, nickel-based alloy. Those alloy can withstand the high temperature, as well as we need to provide some thermal barrier coating, TBC. Okay, so that is one limitation of using this aluminum, not limitation or limiting areas where we cannot use the aluminum alloy in the aerospace domain. Okay, now I'm moving to the aluminum in the railway location or the railway domain. In railway, we know that there are three modes of transportation generally we have. One is this metro, another is the passenger coaches, another is the wagons. Is generally used to carry for carry for the commodities. So in the metro location, previously our metro was built with the steel bodies. Okay. Now, from last 5 to 6 years onwards, our metros are no longer manufactured with the fully steel bodies. Now it is moving towards the aluminum bodies. And you know that India's first indigenous metro, Pune Metro, it was built with aluminum body. And you know that this side panel of this aluminum body, it is the cross section is something like this, where it needs to have the lighter as well as the it needs to have lighter as well as it needs to have some provide some sufficient strength. So stiffener are added. So this kind of section, it is very difficult to produce. And you may be amazed that though we are manufacturing these aluminum body metros, but still we need to import this extruded panel from overseas. So that is one research areas or the development areas where our Indian companies or Indian researchers are doing. So these panels are generally imported from the Europe or China. For this Pune metro, it was imported from the China in 2017 something time frame. So the cross section of this aluminum body, the side panel is like this, and these panels are made by the extrusion process. So India's first indigenous metro, Pune metro, it was completely built with the aluminum body. And now onwards, the Surat metro, Indore, Kochi, then Baroda. So all are coming with the aluminum bodies because it is lighter and the speed is also going to be higher. The fuel consumption is going to be lower and it will have the higher throughput. Okay. Now you can see that this train is nowadays making good noise because this is Vande Bharat, and this Vande Bharat, the initial years, it was made with some metal version. That is called the second generation, which is having the design speed of 180 kilometers. So after that, the third generation, which is now manufacturing with the help of aluminum alloy. We call it is third generation, and its design speed automatically increases from 180 to 200 because it is lighter. So you know that the sleeper version of the Vande Bharat is coming shortly, maybe within a year, and those are made of with the aluminum alloy, and it will be a lighter version. So this lighter version Vande Bharat train will have higher speed and it will have the lesser track loading density. Lesser track loading density means the total amount of load on the railway track is coming on the due to the movement of the train is called the track loading density. So once it is becoming lighter, then track loading density is obviously the lower, and obviously the it will have the higher track life. Presently, that track life India is not that much good, but if we can able to reduce the weight, then track loading density is going to higher, and the higher track life we can get. And the third and then another point is that is the low carbon footprint. So low carbon footprint means sorry, low carbon footprint means the amount of carbon it is, or the amount of fuel it burns to operate these things. So once the fuel burns, the carbon emission happens. Sorry. So if the less amount of fuel consumes, so obviously the carbon footprint will be lower, and it is a sustainable design, and aesthetic wise also it is good. So uses of the aluminum in the coach is in high demand. So this is a typical elite class train from the Indian Railway, which is purely manufacturing in the aluminum domain. Apart from this, the other trains like Shatabdi, Rajdhani, or other categories train are also Amrit Bharat. There also some portion of the aluminum are presently used. Though the entire body for those trains cannot be replaced with the aluminum fully because of the other constraint. So as much possible, the aluminum are used. especially in the interior location or in the seating panel or other location or the toilet laboratory location, the aluminum are used. Okay. Now this is very important, and I will explain why it is very important, because I have worked with this project for the Hindalco, and it is a very successful project. So maybe you have seen this first picture. You have seen this first picture in your railway track. So this wagon is called the BOBRN wagon, and it is generally used to carry the coal. So this wagon is presently used material as a IS2062. IS2062 is a mild steel grade metal. And Boxen HL wagon, that is also used for the carrying the coal, that is used as a material, that is the IRSM 44. IRSM 44 is a lower grade of the stainless steel, which is relatively good, give good corrosion resistance compared to the BOBRN wagon. Now, for an entire wagon, entire rake of the train, once all the wagons combined and it goes, we call it as a rake. So for a rake, Boxen HL wagon, 58 wagon are there, and one brake van. Brake van means where the at the end of the wagon there is a guard is there who can direct whether all wagons are intact or not. But imagine that for a 59 wagon, so when the turn is taking, so driver may not be able, or the pilot of the train may not be aware the last it was connected or not. Maybe some cases it derailed or so. That's why the brake van is there at the end of the scene. So that is called the brake van. So this 59 comprises a rake, and this is for the Boxen HL, and for the BOBRN it is 61 plus one brake van. So this is called one rake. Now this entire body of this wagon, it has been replaced with the aluminum alloy. It is full aluminum body. This is, you can see that, and imagine, and you will be amazed that in this location, to manufacture this entire body of the wagon, welding it is not used. Only it has been riveted. So this is the panel, and it has been riveted. And the below of these things, it is as it is. I mean, from this underframe, it was as it is. From the top position, it is replaced with this aluminum. So this project, it was taken by Hindalco and the Texmaco jointly. So we had designed these things, and there are a number of design parameters are there, like it needs to satisfy the vehicle dynamic condition, static condition, then trial run, it needs to happen. So all things it has been passed, and Hindalco has produced this aluminum wagon, BOBRN wagon, 5 rake for their own use initially, and as it is going to be expanded to the other wagon lease companies. So now the beauty or the advantage of this uses of this aluminum is that as aluminum is lighter compared to the steel, it is 1/3 lighter. So the upper portion of these things, it has been made with the aluminum. So for a 61 wagon, almost 180 ton weight can be saved. That means per wagon, it is almost 3 ton. Almost 3 ton is saved. So this 3 ton saved, that means the tear weight, or means the empty weight of the wagon, we call tear weight. So the tear weight of this wagon is 3 ton less. That means you can carry 3 ton extra material per wagon, or 180 ton extra material per rake. So imagine that the cost of 180 ton extra material or extra commodity that you can able to carry is enormous. And you know that our Indian Railways, 95% of the revenue are coming from the freight transportation, like the wagon or the other box. And especially India, we are having two dedicated freight corridor. One is the eastern dedicated freight corridor and the western dedicated freight corridor, where only the wagons or the commodities can go. So it has been specially designed in order to increase the efficiency of the commodity transportation, and also some cases to use the perishable goods, like those items which needs to be transport very fast. So here it can capable of carrying 10% higher load. It consumes a lesser energy, and also it can reduce the carbon dioxide emission. And you will be amazed that 14,500 ton per of its design life it can save for one rake. And you know that for one rake, the design life is 25 years. So after 25 years, the wagon generally it is scrapped, or some cases it needs to rechecked, and by 5 years phase it can again renew. But anyway, that 25 years is not a small amount of time for the wagon. But still, the aluminum version of the wagon, as it is newly produced, so we do not know whether after 25 years what will be its condition. But as per the assessment, it will be far better than the conventional material wagon, like the Box NHL IS2062 or ISM 44. Now, here all the advantages you can see, but there is some disadvantage. Disadvantage is that you may be seen that in the coal industries, when the coal comes from the mine and the power plant, the coal needs to unload. And do you know how it is unloading? The tippler is used. That means the wagon comes, and there is a coupler. So coupler, and there is another coupler. So these two couplers are detached. So this becomes single quantity, and a tippler hold this entire wagon, and it's tipple, means it is tipple from the top side to the up, and its entire coal comes to the gravity, due to the gravity. Now imagine that it is relatively hard, this metal, but in the aluminum version, it is not that much hard to sustain the tippler pressure. I mean, it can easily capable of taking the load of transportation and carrying all those things, and during the dynamic and the other location it is. But the tippling, it is just pressurizing. The tippler is pressurizes, and this is revolve the coal. So usage of the tippler for this aluminum wagon, it may not be the good advisable. So that's why for the Box NHL wagon, which is basically used for the power plant location for using the coal, in that location it is not recommended to use the aluminum version. But for the other location where the power plant, where the other location, like apart from the power plant, it is advisable. So there are possible areas where you can combine for aluminum or other location. Okay, so now we are moving to the next, that is some application areas, and what are the areas we can explore, like car body structure, like metro, high-speed train, 5 series and 6 series metal aluminum alloy can be used. So we can get 20 to 30% lighter than the steel. These are the series we can use. Apart from these, roof, sidewalls, underframe panels, we can use these things. The one good advantage is that structural integrity and crashworthiness point of view, aluminum alloy are quite good. Door and windows location we can use, bogie frame we can use, brake system. Brake system is a very unique things in the railway. It uses the air brake, and when the pressure is less than 5 kg per centimeter square, the brake applies. So, so the brake system we can use the aluminum alloy. Flooring location, interior like seating, luggage tracks, fittings, series we can use. Ceiling and the decorative panels we can use. Pantograph in the overhead, OHE, overhead equipment we can use. HVAC we can use in the duct, in the heat exchanger location we can use. Marine and the chemical resistance we can use. So I can give this example. Let me elaborate this one. So we know that wagon are used for carrying the coal, commodities, or all other things. But you know that in Indian Railway are looking a good solution for carrying the salt, because if you carry the salt in a conventional wagon with made of the mild steel, it will corrode within a year. So initially the fiber, the composite fiber panel, it was thought of, but fabrication of the composite fiber on the steel structure, and again its dynamic aspect, it is not giving the favorable result. So that's why the 5 series alloy with some sort of coating can be used for carrying the salt, fertilizers, which is corrosive. So that is one good example. Another thing is that these extruded aluminum profiles, which can be up to 30 meter long, it can be produced. And so that we need not to go for welding for a particular coaches. So for a single coach, we can go for the single panel. And you know that in the worldwide, Shinkansen, which is the Japanese high-speed carrier train, high-speed train, speed something around 500 kilometer. TGV is the Trans Grand Vicente, which is literally English name is high-speed train. In France, their speed is something around 350 to 400. In Germany also. So there also uses of aluminum alloy in the various location is quite. Okay, now we are coming to very good example of the OHE equipment. OHE means overhead equipment. You can see that this is a tunnel. In the tunnel, there are limited space. So the overhead equipment or the electric wire, it needs to be, it has no sufficient space for the electric wire. So that's why it is a special type of arrangement is designed. It is called the rigid overhead catenary system, ROCS. You can see that this is the ROCS, rigid overhead catenary system. This one. This one. And this is the closed view. This is the closed view. And the profile of this rigid catenary system is this. And inside this, there will be a copper wire. Copper wire, which is basically the live electric wire, which will touch the pantograph and it will glide. So this is made of aluminum 6101B T6 alloy. And it is 100% indigenous, because this kind of things, it was available in the European country, but few years back, it has been indigenously developed, and now it is manufactured with for the OHE equipment. And I have worked for this project with one Noida-based company, PPS International. So where we have performed its performance, its structural parameter, then its running speed, like when it goes to 100, 200, 150 and 200. So how it behavior is going to be happen. So that's now this panel, it has been designed up to speed of 200 kilometer. So maybe if time permits, then I can show some So we did this analysis for the, you can see that this is the rigid overhead catenary system. So we did this analysis with the various type of load, like 80 kilometer speed. Then one is the panel length is 6 meter. Then what is the stress is coming for each and every component is when his speed is 160. Then we perform all this type of analysis. So once it has been satisfied with this analytical result, it has been fabricated. And this is the panel, where it has been fabricated, and the test has been conducted in the RD. So now it has been implemented by the, or accepted by this Indian Railway Governing Authority, like it is known as the RTSO, Research Design Standard Organization, which is situated in the Lucknow. So these are the some example or the analysis result which we have performed for this ROCS. Okay, so I'm not going in details about all these technical details or the design parameter and the stress values, all these things. But anyway, we can come back to our original presentation, that this is a very good example where we can use the aluminum alloy. Aluminum 6101B T6 is used because in India, a lot of tunnels and a lot of location where there are limitation of the space or underpass location. So all this location we can use these things. Now, second one is also very important. I worked for this project, and now it has been accepted by RDSO, and it is presently being implemented. So you may have seen that in the electric location, where in this location the pantograph goes. So this is the contact wire. Okay, so in the contact wire the pantograph touches and it slides. So this is called the mast. You can see that this is called the mast. This is called the straight tube. This is called the bracket tube. This is called the register arm, and this is the contact wire. So there is two types of one is a beam type and this is the tube type. So so presently this material, it is used as a galvanized steel. Now this galvanized steel, it is quite heavier, and some cases it is creating some problem due to the wind load or some other kind of hazardous application. Now the project, it has been taken that it can be replaced with the aluminum 6082 T6 material. You can see that. So we model these things with aluminum 6082 T6 material with this various type of these things. So you can see that this is the model, and after successful iteration, we have determined the suitable cross section of this straight tube, bracket tube, register arm, and other things. So once we have completed our analysis, it has been fabricated, and it has been successfully tested, and now it is being implemented through some location. So once it goes for the trial run, like in Indian Railway, if you are changing something, you cannot directly change for all the locations. So you will get a particular 1 or 2 kilometer span. In that location, it is going to be implemented, and it will be trial run for 1 year, and then based on its performance, it can be augmented. So now it is in the trial run stage. Okay, so for this, let me open the another things, like I did this work for one Baroda-based company, which is the Omni Transmission. So maybe you can see that there are various type of load are there, like vertical load, wind load, then snow load. Snow load means some cases when it is going to the hilly region, then on the catenary wire there will be a snow. So then radial pull load, stagger load, all the different types of load, and then some cases there will be a straight track, some cases it will be the tangent track. Then we have performed this finite element analysis, and based on the its stress and the deflection values, we have determined the specific sizes. So we got that 55 OD and 6 OD. No, we got that 70 millimeter and wall thickness 4.5 is better design, and the material is aluminum 608. So presently it is being implemented on a particular location. So it is the RDSO draft specification. It comes under the TI. That means RDSO is having different department like mechanical, civil. TI is the traction department. Okay. So now we are coming back to the next one that is very important. You may be seen that. Let me give one example. Suppose your wagon is carrying some commodity and there is some overhead wear. So if you want to load some material on the wagon, how you will load the material? You have to load the material by means of crane or by means of some other things, because you cannot load from the top, because in the top there is a live contact wire or electric wire are there, okay, through which the pantograph is touching and it will wagon will run. So there is one arrangement, it is called that retractable rigid catenary system. Retractable rigid catenary system, what it does, it generally it is this kind of aluminum panel is there, where inside there will be a live wire. This is the copper wire. You can see that this is the cross section. If I take a cross section over here, I will get this kind of section. So this is the live copper wire, which is basically the current will flow. And the beauty is that when you need to load the material from the top, what you will do, you will retract this entire things, and it is foldable. You can see that there is a hinge, so it is foldable. So that means the entire things it will go over in this location, and this entire location it become empty. So now from the top, you can, with the help of silo, you can load the wagon, and the loading can be done within a minute. Once the loading is done, again this one is retractable, so it can take to its original shape. Now your pantograph is working, and you can check your wagon throughout location. So you can see that how easily you can load the material which was earlier not possible. So in order to make the wagon loaded, earlier it used to take, for a rake, it used to take almost 1 day, but here it can be loaded within a year, within an hour. So this is very innovative project, and I am involved with this project where the PPS International is the main stakeholder of these things. So they have provided us this project to IIST. Okay, so now I am moving to some other things, like so there are a lot of applications are there in the railway domain apart from the metro, coach, passenger coach, and wagon. A lot of other locations like overhead equipment or some railway track equipment also, some location can be used. Okay, now we are coming to the last part, that is the biomedical application for the aluminum alloy. So we need to first keep in mind that aluminum alloy is not that much a good biocompatible material like titanium alloy or magnesium alloy. It is not that much biocompatible material. That means it is not good fit for the internal human body application for the aluminum alloy as a implant, because it is biocompatibility quite less than the titanium or magnesium alloy. So still we are having few locations where we will be having artificial limb, which is not directly going inside to the human body. Like we are not implanting, we are not doing operation inside the human body. So like artificial limb, like prosthetic components, joint parts, external fixtures, where we can use aluminum 2 series, 5 series, 7 series, especially 6061 and 7075 for lightweight and the machinability application. So benefit lower weight compared to the steel, and it is having the improved patient comfort. The limitation is that it needs surface coatings, anodizing ceramic and the polymeric. It needs better surface coating, and so that it can prevent corrosion and that prevents the ion release. So there is orthopedic application. In the orthopedic application, whatever we can use from the external view, we can use. Now, another thing is that dental application. And in dental application, as we told that you cannot directly use your aluminum alloy to use as a dental implant because it is not that much biocompatible. But in the dental instrument and the tool location, there are huge opportunities. You may be amazed that for a ophthalmic surgery, there are more than 400 different varieties of scissors are available. Scissors are available. So which are generally used for the eye surgery. This is only for the ophthalmic use I'm talking about. So there are a lot of other applications like dental or other locations. And the ophthalmic surgery, the ophthalmic surgical instrument is market size something around in India in present day it is more than 100 crore. So and why it is so much so much quantity is needed? Because it is single uses. That means for a surgery it is one time use. Once it is uses, then it needs to be scrapped. It goes to the, like in the syringe, if you one time use, then it is scrapped. So that's why it is, the volume is high and the market size is also big. So in the dental instrument, the tool location, the drill, clamps, impression trays, alloys, mainly the 6 and 7 series are basically used for high strength and machinability. It has the very wide benefit, like it can be easily sterilized, and the corrosion resistance is when it is anodized, it is having the better corrosion resistance. Surgical instrument, as I told, surgical, it can handle the frames, the lightweight tools. Aluminum 6 series, 7 series is used. You can see that all type of surgical instrument are nowadays are using with the aluminum with some sort of anodized coating. Apart from that, sorry, biomedical devices and equipment. In the biomedical devices like wheelchair, hospital bed, stretches, rehabilitation equipment, that means the peripheral of the medical sector, where the aluminum alloy are widely used, like in the aluminum 5 series, 6 series, it is used. It is light, durable, and it is having the good corrosion resistance. Obviously, it needs to be anodized. And like others, like crutches, walkers, braces, support devices. So all the peripheral equipment, location, the aluminum alloys are presently being used. And in the medical industries, the peripheral domain, the market size is also huge. I know that a lot of companies are also procuring this kind of peripheral devices, and the uses of the aluminum are huge. Okay. So a few others, like some research application, like aluminum matrix composites reinforced with bioceramics like HAP, titanium oxide, and zirconia. In that case, we can use. And load-bearing implants like bone substitute cases. Some cases now it is slowly is using with some ceramic addition of the bioceramic. So aluminum metal matrix composite can be thought of, where you can start of thinking of using the aluminum alloy or aluminum matrix composite, not alloy, to the biomedical purpose. And benefit, it is the tailored and biocompatibility is enriched up to some extent, because we are using the hydroxyapatite and titanium oxide we are also adding, and that zirconia is a highly biocompatible. Forus AI structure, aluminum structure, like studied the scaffold, but limited to the toxicity concern. So scaffold is also sometimes is used, but it is limited because it is toxic. Toxicity is there. Now I will take just two example of one of our recently concluded paper. Like one we did study for the aluminum 6061 T6 alloy, and another is the aluminum 7075 T6 alloy. So you know that aluminum 6 series and the 7 series are the heat treatable. So once it's heat treatable, its strength is obviously enhances, as well as its tensile stress is also increasing. So we did a heat treatment cycle. Initially, we increase the temperature from 0 to 500 degrees centigrade, 0 to 540 degrees centigrade, and then it hold for 1 hour. So up to 100 minutes, it increases from 0 to 540 degrees centigrade, and then hold at 540 degrees centigrade for 1 hour, and then it suddenly cool down to the ice cool, and temperature reaches to the -20 degrees centigrade. And again, it temperature increases to 200 degrees centigrade and hold for 3 different time. One is the 2 hour hold, and then cool down to room temperature. Second one is hold 5 hour, cool down to room temperature. And the third one is hold 10 hour and cool down to the room temperature. And we did this experiment and performed the hardness Vickers Rockwell hardness test in B scale and the tensile test in the UTM machine. And we have seen that for 2 hour cycle, we are getting the hardness, average hardness, something around 12 to 13 HRP. So if I go for 5 hours, it is becoming 49. If I go 10 hours, it is 58. So you can see that as the aging time increases, that means the holding time increases, my hardness is also increases. So there will be a saturation point. So after 10 hours, it is not increasing up to significant amount. So 10 hours is the optimum aging time through which we can get the optimum hardness. And we have performed the tensile test for these 2 hour, 5 hour, and 10 hour aging time surface. And then we found that the tensile stress is increasing up to some extent. So after 10 hours, the tensile strength is becoming almost stagnant. So initially it is 2 hours, it is yield point, it is something around 200, and then if we for the aging 10 hours, it goes to 290. So there is significant increase of this tensile stress as well as the hardness values. So this is for the aluminum 6061. It is heat treatable, and this with the desired application and desired hardness we need for specific domain, we can go for the different aging time for the heat treatment. Okay. Another is that, so this is the reference through which our published paper can refer. This is for the 7075 T6. So in the 7075 T6, we did the aging time for 6 different variations. Like one is 15 minute, 30 minute, 60 minute, 120 minute, 300 minute, 600 minute. So these are the samples like A, E, I, O, U, W. These are the based on the aging time it has been designated. Now, so once we have performed this, for this case, we have increase the temperature from 0 to 400 degrees centigrade up to through a time of 100 minutes, and then hold for 1 hour, then cool down to -20 degrees centigrade, and then increase to 120 degrees centigrade, then cool down to the room temperature based on the different aging time, A, E, I, O, U, W. And we have seen that there is a very good observation that for these 6 different samples, we can see that as the aging time increases, so almost 600 minute or 10 hour time, this sample gives the higher values of the Rockwell hardness in a B scale. So you can see that something around from this 15-minute aging time, it was 74 is the average, and this is the average is something around 80. So almost 20% increase in the hardness values, which is a significant value for this kind of material for a specific application. So with this, I will try to wrap up my presentation, and then we will go for the some question answer. So the conclusion part is that so before conclusion, we can see that 6 series is extruded aluminum part are good for the energy absorb condition. Like as I told that for the shock absorbing cases in the railway bogies, if the 2 panels we will use some sort of shock absorber with the 6 series material, then it can be good shock absorber compared to the steel. Then some damping location also we can use. And if we anodized the 6 series, 7 series, then this component stiffener, this component we can use as a stiffener also. Some additive manufacturing route also can be taken for producing this aluminum, silicon, and the magnesium, which is alloy, can be used as a biomedical application. Okay, so now the main conclusion is that this aerospace domain, 2 series and the 7 series are quite widely used, and aluminum and lithium remain the structural workhorses. AM also, additive manufacturing is also nowadays it is playing a good role for the fabrication of the aluminum alloy for a complicated part. And then railway domain 5 and the 6 series are used. It is weldable and it is corrosion resistance, and lightweight carb location also it is used. Biomedical application mainly used for the instrument and the prosthetic frames. Presently in the implant location it is avoidable. In the cross sector it is additive manufacturing application. Through additive manufacturing route, the complicated part can nowadays produced, and the fix and star welding also is used. And aluminum is sustainable, it is easily recyclable, and that's why it is widely used. And though nowadays 2D material graphene is regarded as a wonder material, but aluminum is also kind of a wonder material. You may be seeing that the Aluminum Association website, and you will see that is also regarded as a wonder material because it is having a wide application, wide benefit in the each and every sector. I will give another example. In the last week, we were in the Hindalco Lohardaga site for their bauxite mines, and there are 10-kilometer length long ropeway is available, which carries the raw bauxite from the mines, which is situated on the hilltop, to the Lohardaga railway station. So they are carrying this bauxite by the ropeway through the bucket, and this bucket is presently it is miles, and each bucket empty weight is 400 kg, and each bucket can carry 600 kg material. So the total load for the each bucket with the material and the empty load, it is 1 ton. And with this heavy load, this ropeway is going beyond its vibration limit, and as it is going beyond its vibration limit, some cases the bucket out or the rope out phenomena is happening, means it is bucket is coming out from the rope. So we have apart with all sort of other possible remedies, another remedies we also proposed, like if they can use the bucket for carrying the bauxite made of the aluminum alloy, which is 1/3 lighter than the present steel. So they can, in that case, almost 400 kg. So it becomes only 130. So almost 250 kilo they can save. So this amount of load will not come to the rope. So if the rope will re-establish the vibrational imbalance out there. So with this, I will just going to conclude this, and I will over to Dr. Rao for any question answer session.
Okay,
Dr.
now,
Daud?
yeah. It's okay. Now it is open to all the participants. If anybody wants to ask any questions related to this subject, you can ask.
Good evening, sir.
Good evening.
Is there any biocompatibility issue of aluminum for biomedical applications?
Yes, aluminum is not that much biocompatible. It is toxic when it comes to the human bone, or it comes the contact with the human blood or bone. It is not behaving properly like a titanium alloy or the magnesium alloy. So there is a good biocompatibility issue. That means it cannot be used to the directly implant represent. So aluminum alloy is not a good recommendation for the biomedical implant, but there are a lot of other areas in the medical domain or the medical field where we can use the aluminum alloy. And nowadays, some sort of aluminum composite with this magnesium and silicon, zirconia or titanium oxide, it is under research stage. But still, compared to the titanium alloy and magnesium alloy, it is not recommended as a bio implant.
Okay, thank you, sir.
Okay, anybody else? Okay, sir. Then thank you. Thank you, Dr. Das,
Okay.
for your nice
I
answer. Yeah.
I hope that maybe my slide, it is quite useful and informative to all the participants. And if you are having any sort of question, any sort of relevant data or any sort of industrial insight information you need related to this presentation, whatever I did, you can always contact to me to my email ID, which is already there in my institutional profile. So all are welcome to ask any question.
Yeah, I want to tell the participant that Dr. Das is currently working in IST Sipur, and he has many industrial works also he is involved. So you can also collaborate with him for your work, research work, anything else,
And
for industrial consultancy work also.
And recently you may be knowing that in your Kalahandi, bauxite mines is also coming. So Vedanta is planning to take this thing. So maybe that will also be a good opportunity for you.
Yeah. Okay then. Thank you everyone.
Okay, thank you for inviting me and providing me this platform to present something. And I'll be happy to resolve your query in future also. Okay, thank you.
Thank you everybody. Good
Good
night.
night.
Okay,
Good night.
tomorrow actually we have your sessions. Our sessions will start at sharply at 2 p.m. and it will continue. We have 3 sessions. So all are requested to join at 2 p.m. And after the end of all the 3 sessions, we will have feedback and one that is a test. You have to log in your Autal ID. There you have to appear the test. You may have, Ajit, what is the time period?
6:30. All participants can log in their respective login with the Auto, and there they will find the assessment tab, and you can have the test there. And also, I have shared the PDF regarding this how to give the assessment test. So everybody have a look on that PDF so that it will be clear to all of you. And also regarding the feedback after completion of the FDP, the feedback will be collected from the author side only. So tomorrow there will be only the oral feedback from the participant, but actual feedback that you have to give through the author FDP side after the completion of the FDP. So tomorrow is a very
from 7:30 to 8 o'clock, we have your validation function. So there we will gather together for closing of this FDP, Atal FDP. Okay, thank you, everybody. Good night.
thank you.
Okay.
Thank you, sir.